Hi everyone, really pleased to be here. I'm Laurie Thorpe from IBM, and I have an exceptional team of people here on the panel today that I will go and introduce in a minute. We're looking to make this interactive, and we will be taking questions at the end, so please, prepare, and we want to see them in difficulty with the questions that you ask. So I'm going to start with introductions. Would you like all to start with introductions on who you are, why you're here, and then talk about sort of the emerging and evolving technologies that are going to be impacting security?
Morning, everyone. I'm Suraj Sheikh. I'm a professor in system security at Swansea University. I've been involved in some of the 5G projects in terms of the test beds and ORAN elements as well. So for us, the focus really is about engineering secure systems that use 5G networks, but equally looking at risk assessment and assurance for the supply chain for components, including 5G and others.
Hi, my name is David Rogers. I'm on the UK's Telecoms Diversification Advisory Council. I chair the mobile industry's fraud and security group globally at the GSMA. I do a lot of work with security researchers, so I'm just coming in from 44Con, which is the UK's biggest hacking conference, heading back there in a minute. So yeah, that's kind of my interest, do a lot of work around this space.
Hello, and my name is Scott Alexander. I'm from a company called ARKit, based here in the UK. Our headquarters are. We're a cybersecurity company that's very focused on a number of looming threats. They actually already exist. So things like authentication. How do we know who's actually talking to us? How do we know what things are communicating with us and sharing data? And equally important is the concept of encryption, and the way that we use encryption today across the industry of networking and IT fundamentally has some vulnerabilities that are actually going to get worse with the looming threat of a thing called quantum computing. So we're very focused on looking at the use cases associated with how do we make encryption and security stronger. We are actually involved in one of the original DCMS Frank projects called Secure 5G, and that consists of CS Catapult, Lime Microsystems, and Slipstream. It was really an SDR use case, so software-defined radio use case, and the bit that the ARKit role in this was trying to make sure from day one we think about the security profile and posture of new technologies. How do we make sure that as data transfers between different APIs, how do we make sure that that's really locked down properly? So we'll hopefully talk about that a little bit more as we go through this.
Dave.
Hi, Dave Happy. I'm 5'10". I've got blonde hair, blue eyes, and my hobbies are telecoms, tortoises, and Dorsets. I have the dubious honour, once I get the nod from our august chair, to give you a 2-minute introductory brief to the session, and then I was rather hoping to have a doze because I'm nearly 60 and I'm terribly old. I've worked in subsea, I've worked on the land, I've worked in the air, and now I'm working on the security stuff, and oh God, it's a long job.
So number of emerging and evolving technologies such as AI, quantum, blockchain, they bring a seismic shift in to security, impacting the threat landscape, but also potentially providing new support and new tools for in the cybersecurity arsenal. Suraj, David, did you want to give us maybe a little bit of a 2-minute overview of how you see this?
I thought you'd never ask. I'm quite relieved about that. I'll kick it off and then I'll hand over to you. So 2 minutes, strap in. Right, let's have some participation. How many of you in the audience have been the subject of some kind of cyber attack to your computer at home? Put your hands up nice and high. Okay, I'm guessing that's about 70%. That's pretty good. Thank you for all being awake. That's marvellous. We're holding the audience still quite well. So we clearly do have some kind of a problem here, and this does matters. As chair of the UKTIN expert working group on cybersecurity, one of the comments I had from one of our august members of the group from Amazon was that we're in a code red situation, and that kind of scares me a bit. But how worried should we really be? I want to leave you with 2 or 3 thoughts and then hand over to my colleague from Swansea, Borodar. Cybersecurity is already dead. Long live cyber resilience. So cyber resilience is where it's at, because I can already get through your first line defenses. So think about it. That's quite serious. The second thing, and this is a quote from the World Economic Forum, and do forgive me because I have glaucoma in one eye, so I have to hold it nice and close, but it is a black book, it's got all your names in it. In this context of the widespread dependency of increasingly complex digital systems, growing cyber threats are outpacing society's ability to effectively prevent and manage them. It's a Dunkirk moment. We're not keeping up. I'm not sure we're winning yet. I'm nearly halfway through. We're doing well. Siraj, warm up. Right, a couple of other stats. 95% of cybersecurity issues are a result of human error. That's also a stat from the World Economic Forum. That's last year. 95%. It's not that we don't know what we should be doing, it's that we're not doing it. That's quite alarming. Doesn't mean to say we don't need more research, by the way. Insider threats. 43% of the problem is insider threats. Are we not paying them enough? Are we not looking after them enough? We need to think about these. And then finally, I'm going to ask you to participate with me one more time before I hand over the microphone. Who was the most breached country in Q2 2023? I'm going to ask you, I'm going to name 3 countries, you're going to raise your hands. Was it 1 Russia, 2 North Korea, or 3 USA? Who thinks it was Russia? Hands up. Who thinks it was North Korea? Hands. Who thinks it was USA? Ooh, well done. 855 breaches in every 60 seconds for that period of time. My final comment. So NCSC issued a warning about the kind of attacks and AI and what was going on, and it's called prompt injection attacks, where you can adapt something that has a different output and distorts those conclusions later on. So the first answer to the question is a double-edged sword for security. Well, if it wasn't, they wouldn't have published the guidance. So, but is it a double-edged sword? Definitely. And that's how, in my view, that's how the facts between quantum, AI and blockchain interplay. And at that point, I can shut up for the rest of the session.
Thank you, David. I can't beat that. So I think a couple of things to say, and just to start off some of the ideas here. So in terms of cybersecurity, yes, there are a number of these elements in terms of human error and being a target and so on. But we want to focus on the one thing that I think the telco industry does well amongst some of the other industries, which is to build secure systems. So if you focus on engineering secure systems and essentially engineering of AI or security, that's, I think, where our focus should lie. And what does that mean? That means 2 things. Essentially, one is we need to focus on the design elements, of course, and that whole risk modeling and design is one thing. But this resilience piece essentially is about in-life monitoring of systems. So in many industries, there are standards emerging, there are good practices emerging, which kind of focus the attention on how do we build those systems. And so the point about the in-life monitoring element of it is that unlike safety critical systems, where given certain assumptions, we would consider a system as safe, where the definition of safety would be accepted, and we've all flown and I think we see very good examples of safety critical systems up in the air, but also under the ground and so on. But in terms of security systems, as David here would tell us, the vulnerabilities may emerge, keep emerging, and so we need to manage that. So that resilience piece, I think, is something important. So that's the first thing to think about. It is about engineering secure systems. If we bring an engineering perspective to 5G, to our networks, beyond just performance systems and optimization and so on, then security would be something that perhaps we not overcome, but we manage all along. And the second thing for me, and we can open up on this as well, is I think good security has to and would inevitably come with good economics. So security can't just be a risk management element. It has to be a value proposition and a competitive advantage for us. So we know that already in the race in terms of 5G and the other side of the world and so on. So we've kind of understood the supply chain challenges there and where research in technology has those benefits and so on. So some of that perhaps we need to catch up, but we do need to think about diversification and to think about a competitive supply chain competitive in the sense that which is financially viable, which is able to then offer us a healthy market where we can bring in those solutions and expertise for security. Beyond that or without that, I think it'll be very difficult to sustain that. So I think those two key messages, one is engineering security, and the other is really the economics of security.
So building on you talk about building secure systems. So when it comes to Open RAN and generally open networks, what is the role of AI to improve security? David, do you want to start?
Well, I guess let's start on the function of AI in Open RAN and the Radiohead. Is basically, what we want to achieve is very low latency connections. So, it's not all negative. I think AI is presented quite negatively, always attached to a security context, but let's actually look at the functional uses of it, which is, essentially reduction of labor, reduction of work processing. So what we want to do is at the edge really be able to have some intelligence that can make decisions that in a sensible manner. So for example, for handover, for V2X connections, so for cars on the road and so on, you'd rather do that at the edge where it's closest to get that really low latency connection rather than have to do some processing in the data center somewhere. So that's really the sort of use case for it. There are a bunch of other use cases. I think the problem that we have is the immaturity in the engineering side. So, and this is probably not the right term, but amongst the engineering community, people would say this: you sort of need to engineer for Satan rather than Murphy. So what we mean by that is, you need to look at somebody who is deliberately going out to subvert that system rather than something that accidentally goes wrong and ends up in sort of non-deterministic behaviour. And we've had a few warnings already. So there was a research paper by a researcher called Altaf Sheikh, and he did some great work around self-organising networks. And all he did was set up a false base station, turn it on, which forced the network to reorganize. They turned it off again, and it reorganized, and they turned it on again, and basically created a denial of service on the network just by turning something on and off. And really what the root cause of that problem is the very, very basic code in that software that was probably being sold as machine learning, AI, etc. So I think we have to kind of break down those myths and really actually understand what is being implemented by these companies, and really, for operators particularly, if you're in the room, you actually introspect what is going on and what they're actually selling you. And that's before we get to the more sophisticated things on, so some of the academic research about model poisoning attacks, and you mentioned injection and so on. So, it's an area that we do need to pay attention to, but it might surprise you that as a security person, I also see massive, massive benefit here, and we can use AI in defense as well.
Yeah.
Can I just pick up on the double-edged sword part of it? I mean, absolutely, self-optimizing networks as a concept is not new. I mean, I worked in the 90s on DWM technology, which is very, very complicated. It's all analog, and the system has to stabilize itself. Where we're heading with AI, though, is even more power. And you add AI to some of the concepts that I mentioned a minute ago about quantum computing. The actual way you can take AI just goes into incredibly positive outcomes. Of course, though, you've got to look at it on the other side, and that, used in the wrong way, it becomes extremely dangerous. From our perspective, we are very worried about how we used to deploy networks. I'm a networking guy by nature, and the security part always was secondary. It was like a bolt-on over the top. I don't think we can get away with that as an industry anymore, and certainly I'd like to be part of the UK initiative to make sure that we lead in this space. And what it requires us to do is actually go back to the building blocks of security, and think about, how do we authenticate as a starting point? How do I know that that person in the room that I want to speak to is actually that person? Because in the virtual world, you can't see or physically touch anything. So that's a major issue that we have to solve. And the thing about AI is it will detect weaknesses. So it's good if you're on the positive side of using AI to find things that are not strong, but it's very bad if it's used the other way, to actually find things that are weak and then go and attack. And that's the double-edged sword part of it, the way that I look at AI. Certainly, with my job role, it's to look at the negative side of it, sadly. But there are definitely, there's using AI in order to protect against AI is actually sort of where I think we're heading with this. The thing that's more important to me, that I don't think there's any difference when I look at an ORAN environment. The fact is that we're opening up a lot of interfaces and a lot of data, and AI engines will use that data hopefully in a positive way. But you've got to look at it. What happens if they use it? And I think there was data poisoning type discussions. Those are the things that we need to think about. But going back to the fundamentals, we need to think about how, when things are communicating with each other, how do you know who they are and how do you permanently do that authentication all the time? We've never done that before. And the second thing is, which is actually equally important to me, is about encryption strength. There's lots and lots of APIs that have very weak encryption strengths, and most people don't know. That's the issue, because nobody gets up in the morning and goes, what encryption am I using today off their laptops? Maybe some people do, but there's not many. I doubt there's many in this room. What it really is about actually actively looking at the strength of what you're doing, and actually that's really where I think the industry needs to head, is that initial identification of weakness and then going on the journey of actually making things more robust.
Yeah. So, Suraj, would you like to share some thoughts around the evolving role of AI in the context of network assurance? I know you've been doing some work on that.
So I'll just follow up on, I think what David has said as well, and what I was referring to earlier. So in terms of that engineering aspect, in some of the projects that we've been working on, but more widely as well, I mentioned engineering kind of methodology and standards that are emerging. So what's important there is to factor in the fact that we need to design the systems with a threat model in mind. And that threat model has to continuously evolve as well. And therefore that in-life monitoring of systems. And I think this is very important here. So a lot of other industries are taking, once again, the existing principles from safety critical design. And over there, AI and safe AI is being engineered in from a perspective of very advanced automation. So we all used to automation, and once again, if I refer to the example of aviation, we've seen automation and very high-end automation being used for aircraft navigation and safety and so on. So over here, if we consider AI as the next step, which is fundamentally different in terms of its non-determinism and so on, but still, if we consider that as the next step, then the methodology in terms of having a safety case, having the set of peer reviews, having a regulator approving a safety case, and taking a systems approach to that design and engineering is what we need to adopt. Now that's all very simply said, but it takes years and years. And of course, even in aviation, we see safety is something is still a continuous challenge. But going back to the point about assurance, is that I think we need to have those standards, that mindset that David mentioned too, but also having perhaps a slightly regulated approach where the regulator is mindful of this and is making sure that the supply chain and the operators are delivering to that, because this is one of those things which we can't afford to get wrong in a sense. Ultimately, 5G or other future telecommunication technologies would be underpinning lots of safety critical systems, would be underpinning lots of remote operation systems, not just automotive, but it could be healthcare, it could be other industries. And so it's a matter of life, it's a matter of national security, it's a matter of societal benefit and competitiveness. So all of those things need to factor into why and how we need to kind of accept this overhead as a
But I guess if we think about sort of you talk about the regulators, but ultimately it's also about the controls that you put in place, regardless of whether it's the regulator that's mandating them. Because I think the use, David, you mentioned the use of data. Data is great, but data can come up with conclusions that may or may not be what we need. And I think that is part of that double-edged sword, is how do you use this data?
Yeah, there's two things. The reason I'm smiling is because we were on a project together on automotive, future automotive, and we had to attack a system that was protected by a monitoring system. and my guys decided to, instead of attack the system directly, go after the monitoring system.
Right.
And this monitoring system was detecting attacks against mileage clocking. So anything that tried to change the mileometer, the odometer. And so we attacked the monitoring system that was correcting this and managed to get the odometer running backwards. So full marks for my guys. But I think this is the danger, isn't it? Sort of we're moving around, we're moving the problem into other spaces and shifting and maybe duplicating the problem. I think in terms of the sort of controls and things for operators, so I'm giving a talk tonight actually about the GSMA CVD scheme, so Coordinated Vulnerability Disclosure, which is well understood. The GSMA runs the world's only industry-wide CVD scheme, and we see a lot of really, really interesting issues coming from academics and so on. And I was categorizing these things, and I was looking that actually a lot of the issues are down to misimplementation on the ground. In a lot of cases, the standards aren't the problem, that they actually got it right. In a few cases, we need to fix the standards. But in the vast majority of cases, it's actually how it was implemented on the ground. And attached to that as well is, for the mobile industry, the biggest problem we have is legacy. So I call this a kind of Janus problem. So in one sense, I'm kind of looking forward to post-quantum and what we need to do there. The apocalypse in 2038, and look it up. That's going to be a big problem for 6G. And then at the same time, I'm having to deal with the problems of private spyware and issues around signaling system number 7 on GSM, designed in the 1970s, or ASN1, designed in 1984. So I think actually going forward, and this is attached to this whole AI issue, because we're defining what 6G looks like now, whatever next future generations are, I think we actually have to make some really hard decisions. And we cannot continue with this security and technical debt. We cannot afford it. You talked about economics. Even in a rich country like the UK, operators are really struggling to implement the TSA, PSDI, apologies for that, and all the other legislation and regulation out there. Now, all of that is a good package, but those guys can't get it right. So what hope does an operator in Sudan have, or in Somalia? And we're all interconnected, so we will rely on that. And the attackers will use those countries as staging points to jump onto the interconnect and attack. So what we really need to think about for the future is whether we need to separate those future networks, logically separate them, so that we can still operate that legacy stuff, but we're kind of wrapping 6G and future networks in cotton wool and not exposing them to kind of bidding down attacks and interconnect issues that we see now. And that will help us to concentrate on dealing with future issues like AI.
Yeah. Given all of these points that we've raised and all of these changes that are happening, what would you all like to see happening in the future, and how do you see the government helping with that or supporting?
Do you know, I thought you'd never ask. Luckily for you, I have a quote prepared. The question is, will I be able to read it with my eyesight? So you're all about to find out. So this is again from the World Economic Forum, the risk report from 2022. It's quite a long one, but basically it says government at all levels face mounting responsibilities, and many are struggling to uphold their end of the digital social contract. And they then specify a whole range of things that would be impacted, from securing critical infrastructure, addressing episystemic security, which I thought had something to do with my belly button. That was quite confusing. Disinformation, protecting the integrity of civil processes and public services, legislation against cybercrime, training we need to come back to. I noticed that there's an awful lot of middle-aged, middle-class men here. I'm not proud to be one of them. We've got to be much more open-minded, and we need the wisdom that other people from whatever background, whatever sex or age, we need all of that experience, and it's just not good enough, and we're not doing well enough. And I've been trying in my own little way to help with that one. They also go on about cybersecurity in a more general sense. They talk about ensuring protection even of rare earth metals. There's so much we need to do. And my summary to government would be, we need to do something like the Koreans did. It's called an information strategy. You might want to go to the all-party groups and take this away from politics and say, we need a 20-year plan. We cannot continue to fund this on 18-month cycles. It just doesn't work because the people attacking our networks only need to get in once and we're all screwed. That's my summary.
Thank you, David. Who would like to go next?
That's a bit tricky. All right, following that one. I'd like to go back to some more basics, which the government can certainly help us. If you look at what the White House is doing at the moment, they're actually coming up with national security memorandums and being very vocal about what scares the government and the national critical infrastructure, CNI, I should say. And actually, they're giving guidance, and that's actually what I think we'd like to see here. So there are certain things at the moment on the way that we do things in networking that are very well known. We as an organisation, are concerned about the use of PKI and the ubiquitous nature of it, because effectively we are sharing information about the keys that are being used, and you can see it in public. And as things become more open, things become more visible, more transparent, and blockchain is a great example of that, because if you actually look at the real value proposition around blockchain, effectively it automates trade. Right? You can instantly see where anything is and where it is around the world and who owns it at any point in time. Fantastic, it will speed up everything and make us all more efficient, better economics, all that thing. But the reality of opening that up, you then have a massive security implication of what happens when that gets breached, and the sheer numbers, value of some of that trade that's going across the globe, and it opens up a whole load of concerns around encryption technology and everything else, and that's where I think the government needs to help us just make sure that everyone's aware. There's lots of things that I do believe we should be doing right now, and that's discovering what we do now, whether or not it's on legacy technology or new gen stuff as we're building it. You can see it's quite easy to have tooling to actually have a look at what you're doing. Where's your data going? What is it? How critical is it? What encryption are you using? And are you doing regular authentication? And that sort of guidance is what I'd like to see our government give.
Yeah, and I think that actually the understanding of what we're doing now and how we're using encryption, I think that's a really critical one that often gets overlooked.
It's not a very exciting subject, I'm sorry everyone, but the reality of it is very important because it's the way that we protect ourselves.
But there is a lot of guidance there. I think it's not true to say that the government hasn't given the guidance. So NCSC's put out a lot of really great guidance. If you look at post-quantum, the NIST have been working on this for an extremely long time. The US government's taking it very, very seriously. I think my sort of thought in my head when you were saying that said, we need to get rid of PKI and replace it with what? I think this is the problem that we've got. It's not, blockchain's a kind of sideshow for me. We're baking in PKI into, authentication for smart EV charging, for example, now. It's standardizing every single interaction that we do. So really, I know Laurie's being very quiet here, but Laurie's leading the work in GSMA on post-quantum. So implementing quantum-safe cryptography into cryptographic libraries so that we are sort of crypto-agile for the future, so that we can swap out those existing insecure PKI, prime number-based algorithms, elliptic curve-based algorithms, with something that's going to stand up to quantum computing. And that's really the huge program that all these technology companies are working on right now to protect us all. So I don't think it's as simple as swapping out PKI.
I don't think actually swapping out is the right term, to be honest with you. It's more around the fact that we have become very dependent upon it. There are certain ways that you can actually lock down. We've opened everything up. The internet was allowing everyone to talk to each other, communicate with each other. You can create private networks over the top of the internet. Right, you can do that with encryption, and when you do that, though, you don't necessarily want to use things like PKI. We are very attached to the use of symmetric keys, because effectively, if I can get a key from me to somebody in the audience, only that person and me will be able to communicate as we encrypt. It's a very complicated thing to do, and there's different mechanisms. There's topics associated with using quantum physics to do that. You can use mathematics, and you can use other techniques that we use around a key agreement. So there's definitely multiple ways of doing this. I don't think it's a replacement, but it's like an upgrade. That's the way that we're looking at it.
Yeah. Suraj, anything to add?
Nothing to add.
Okay. So I wanted to leave a bit of time for the audience. Are there any questions?
Thank you. To me again. I'm going to put another hat on. I'm going to put my NICC chair hat on for the time being. So you mentioned SS7 earlier. It's interesting that I don't know who's phoning me up these days. So I often get phone calls where somebody has somehow got into the system and a call centre from a different country has managed to call me. So are we really focusing on the right areas of security moving forward? I mean, for 5G, I've lost count of how many keys we have to derive in our phone because it is so super secure. But at the same time, if I watch a YouTube video on my phone, it gets encrypted about 3, maybe 4 times, all of that using energy. So how are we going to look forward to reduce energy consumption while maintaining security?
Right, it sounds like there's about 10 layered questions in there. Right. How long have you got? So I think you pin the tail of the dog here, right? Because we do need to get rid of that stuff, right? And some networks across the world are turning off 2G, for example, to free up spectrum, and that's a great thing. I saw actually that the EFF put out an article saying that Google and Apple are putting in extra mechanisms to protect subscribers from connecting to networks like 2G where they may be subject to certain types of attack, particularly around spyware. And I think, as I said before, I think this is the core issue here, is there will still be a lot of legacy. When we're in 6G, LTE will be legacy, and there'll be new attacks on LTE. So we will never, ever get away from this problem. At some point, whatever future networks come, 6G, that brand new security in 6G will be broken by some technology that we're not aware of yet. So it's about living with legacy. Then on the sustainability part, I mean, it's an economic, the security argument may also help to drive the economic argument and the general sustainability argument for operators to say, do you know what? The combination of all of these things means that it's unsustainable to maintain these legacy networks, and governments may also do that. And it's not just a question about freeing up spectrum. It's about safeguarding the network, and it's about safeguarding subscribers, including those that are on 6G devices.
I'll chuck in a little bit. The person phoning you up, Howard, was me. I travel widely. The other thing to do with energy, obviously it would be improper of any panellist that's living and working on a regular basis in Dorset, not to mention the superb multi-award winning Rural Dorset programme. So we'll get that out of the way, but we'll say that in the new programme to be announced, that's been announced today, looking at some of the innovative energy saving technology that we might be able to work with from people like ARM, may assist in that regard. Can I answer that question for you today, Howard? No, I can't, but I'll phone you up as soon as I've got the answer.
So we have time for one more question.
Hi there, it's Julie Bradford from Real Wireless, and I guess just in keeping with the theme of today's event, which is around open networks and open RAN networks, and I'm just interested in views from the panel in terms of the maturity of securing open RAN networks, and then what's the additional cost of securing an open RAN network compared to today's cellular networks, and what's that kind of cost overhead, if you like?
Can I just, I'll just try to start that, and assuming the rest of the panel will pick it up quickly. But my view on it is that protecting open networks is actually around using technologies that we already have, but it's actually, again, it goes back to that reinforcing the best that you can possibly do. So everything is about economics. So secure, we've discussed that already. I mean, obviously, we've got to make sure that O-RAN networks are economic and deployable when you compare them to Wi-Fi, but Wi-Fi has lots of security weaknesses in it anyway. So actually, we can actually make it stronger and more secure than Wi-Fi, as an example. For me, a lot of it is actually about just good use of existing things we already know about, and we just progressively, reuse things. So I don't think there should be a massive incremental cost if we do it properly.
Anybody else want to?
Well, I think, it's realistically, as I mentioned before, there are a lot of things going on in parallel. So, secure by design in general. There's been a lot of scrutiny on the security of O-RAN. It's obviously going through ETSI now. BSI in Germany commissioned a report that found a lot of holes in it and so on. So I think, one thing to consider in all of this as well is that as part of that openness, that means third parties could potentially add security as well, which means a better exposure of the telemetry to, for example, to SIEM and to people in a SOC, which at the moment is quite invisible to them. So I think it's difficult to say what the cost is when actually the benefits of it, I think, balance it out quite well.
So I'd like to thank the excellent panel, and thank you all for listening.